Hello guys, welcome to i-tutor Academy. In today's session, we will start with the Unit 2, that is Presentation of Data, MMPC 005. So let's see the objectives of this chapter. So objectives of this chapter are, after studying this unit, you should be able to understand the need and significance of presentation of data, know the necessity of classifying data and various type of classification, construct a frequency distribution of discrete and continuous data, present a frequent distribution in the form of bar diagram, histogram, frequency polygon and ogives. And structure of this unit are, there is an introduction of their classification of data, objectives of classification, type of classification, construction of discrete frequency distribution, construction of a continuous frequency distribution, guidelines for choosing the classes, cumulative and relative frequencies, charting of data, summary is there, keywords are there, self-assessment exercises also there. So let's begin with the introduction part. In the previous unit, we discussed the various ways of collecting data. The successful use of the data collected depend to a great extent upon the manner in which it is arranged, displayed and summarized. In this unit, we shall be mainly interested in the presentation of data. Presentation of data can be displayed either in tabular form or through charts. In the tabular form, it is necessary to classify the data before the data is tabulated. Therefore, this unit is divided into two sections, that is classification of data and charting of data. Classification of data. After the data has been systematically collected and edited, the first step in the presentation of data is classification. Classification is the process of arranging the data according to the point of similarities and dissimilarities. It is like the process of sorting the mail in a post office, where the mail for different destination is placed in different compartment after it has been carefully sorted, cut from the huge heap. Objectives of classification. The principal objective of classifying data are to condense the mass of data in such a way that salient features can be readily noticed, to facilitate comparison between attributes of variables, to prepare data which can be presented in tabular form, to highlight the significant features of the data at a glance. Type of classification. The some common type of classification are geographical according to area or region, chronological according to occurrence of an event with respect to time, and qualitative according to attributes, and quantitative according to magnitudes. Geographical classification. In this type of classification, data is classified according to area or region. For example, when we considered production of wheat state-wise, this would be called geographical classification. The listing of individual entries are generally done in an alphabetical order or according to size, to emphasize the importance of a particular area or region. Qualitative classification. When the data is classified according to some attributes, that is distinct categories which are not capable of measurement, is known as qualitative classification. In a simple or dichotomous classification, an attribute is divided into two classes, one possessing the attribute and the other not possessing it. An example also there. And quantitative classification, when the data is classified according to some characteristics that can be measured, it is called quantitative classification. For example, the employee of a company may be classified according to their monthly salaries. Since quantitative data is characterized by different numerical values, the data represent the value of a variable. Quantitative data may be further classified into one or two types, that is discrete or continuous. The term discrete data refers to quantitative data that is limited to integer numerical value of a variable. For example, the number of employees in an organization or the number of machines in a factory are example of discrete data. Continuous data can be take integer as well as fraction value of the variable, and example also there. When the data is arranged into groups or categories according to conveniently established division of the range of the observations, such an arrangement in tabular form is called a frequency distribution. In a frequency distribution, raw data is represented by distinct groups which are known as classes. The number of observations that fall into each of the classes is known as frequency. And here is a activities are there, try to do that. And next is construction of a discrete frequency distribution. The process of preparing a frequency distribution is very simple. In the case discrete data, place all possible value of the variable in an ascending order in column, and then prepare another column of tally marks to count the number of time a particular value of the variable is repeated. To facilitate counting, block of 5 tally marks are prepared and some space is left in between the blocks. The frequency column refers to the number of tally marks a particular class will contain. And next is construction of a continuous frequency distribution. In constructing the frequency distribution for continuous data, it is necessary to classify some of the important terms that are frequently used. Class limits. Class limits denote the lowest and highest value that can be included in the class. The two boundaries of a class are known as the lower limit and the upper limit of the class. And the class intervals. The class interval represent the width of a class. The width may be determined by subtracting the lower limit of one class from the lower limit of the following classes. And class frequency, the number of observation falling within a particular class is called its class frequency or simply frequency. Total frequency indicate the total number of observations considered in a given frequency distribution. And class midpoint. Midpoint of a class is defined as the sum of class limit divided by 2. And the type of class intervals, there are different ways in which limit of class intervals can be shown, such as exclusive and inclusive method and open-ended. Exclusive method, the class intervals are so arranged the upper limit of one class is lower limit of the next class. And inclusive method, in this method the upper limit of one class is included in that class itself. So here is an example, so you just refer the example so it will more clear. And open end, in an open end distribution, the lower limit of the very first class and upper limit of the last class is not given in distribution where there is a big gap between minimum and maximum values. The open end distribution can be used such as an income distribution. And remark, to ensure continuity and to get the correct class interval, we shall adopt exclusive method. However, if inclusive method is suggested, then it is necessary to make an adjustment to determine the class interval. This can be done by taking the average value of the difference between the lower limit of the succeeding class and the upper limit of the class. And the correction factor is here. So here is the formula. And so this is about today's section. Next section of unit 2 subsection 7 we will discuss on next video. And in between any doubts, you just contact us on our number, or you can comment it on our comment box also. And for more MBA Ignou videos, you just do like, share and subscribe our channel, and thank you for your support.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.